So hi, this is Arvind Raj, and I'm going to present you about Class B power amplifiers. So we knew that power amplifiers could be classified into four types as Class A power amplifier, Class B power amplifier, and Class C power amplifier, and Class AP power amplifier. So with respect to Class A power amplifier, the output voltage is going to be same as input voltage. Like the output voltage would be obtained with 360 degree, but with respect to class B power amplifier, the output voltage will just be 180 degree, like only one half the input waveform, which is output voltage, but still the efficiency of class B power amplifier is going to be higher than that of class A amplifier, and that's why we go for something called class B amplifier. So as you could see, class B amplifier is a type of power amplifier where the active device transistor conducts only for one half cycle of the input cycle. So since this active device is switched off for the other half cycle, the actives dissipates less power, hence the efficiency is improved. So these are some graphical representations of class B power amplifier. So this is what that will be taking place during positive half cycle and negative half cycle. Like as you could see, there are going to be two transistors here, and this is a representation of class B amplifier. Like as you could see, the graph given for above is the class A power amplifier, and the graph given for below is the class B power amplifier. So class B power amplifier could again be classified into two types as push-pull class B amplifier and the complementary symmetric class B amplifier. So in case of push-pull configuration, like we'll be making use of two transformers, two center tap transformers. One transformer will be acting as the input transformer. This is also known as driver transformer since it drives the complete circuit, while the other transformer is going to be the output transformer which connects the load to the output, right? So these two transformers are going to be center tap transformer, and of course we'll be making use of two transistors here. The two transistors will be of either NPN type or PNP type. But the major disadvantage of push-pull class B power amplifier is that it will have something called crossover distortion. So this is the advantage and disadvantage. Then we have one more type of class B amplifier called complementary symmetry class B amplifier, where we don't make use of transformers. Since we're not going to make use of transformers, it's going to be cheaper. Also, it very slow, and also the frequency response is going to be improved. Also, the overall efficiency of complementary symmetry class B amplifier is going to be greater than that of class B push-pull amplifier. But the only thing is that it requires two input signal. So here are some representation for the IDC current and the power output. So the power is going to be 2 pi VCC into the input current, and basically the efficiency of transformer is the output power by the input power. So output power is going to be PAC by input power into 100 is going to be the efficiency of transformer. So the power dissipated by the output transistor could be given as uh, P input minus P out. This is going to be power dissipated by the transistor. The power dissipated across each transistor will be the total power dissipated divided by 2. So this is the transfer characteristics. Yeah, as you could see here, the IDC power is going to be IEC max into IDC, and this is some representation of the power efficiency of class B push-pull amplifier. And as you could see from the calculation, the maximum power efficiency of class B push-pull amplifier is going to be 78.5%, whereas in class A power amplifier it was just 50%. Therefore it's going to have overall increased efficiency. Yeah, this is the circuit diagram for complementary symmetry push pull amplifier. Like as you could see here, there are no transformers used here. we'll be using NPN and PNP transistors here. So like we have both advantages and disadvantages of complementary types class B amplifier when compared to that of class B push pull amplifier. So this is the advantage and disadvantages. So coming to crossover distortion, like if you see in class B amplifiers, the transistors are biased cut off. So these transistors can enter the active regions if only if the base emitter junctions is forward bias. So to forward bias these junctions, the input voltage must be greater than the cut-in voltage of the junction. Thus, as long as the input voltage is less than the cut-in voltage, transistor will remain in offset and the output will be zero. The output of the signal gets distorted near zero crossings. So the distortion is called crossover distortion. So this is what called crossover distortion, and hence the conduction angle must be less than 1 degree. So this is a major limitation of class B amplifier, and that's why we are moving on to some more kinds of amplifier like class C power amplifier and class AP power amplifier. And this is the representation of crossover distortion.